So this video covers activation functions, and from the previous lecture you have maybe remembered that we have the sigmoid activation function used in logistic regression. So this is the so-called logistic sigmoid function, and this is applied twice. So activation function adds nonlinearity to the model, and with only one single hidden layer, having a nonlinear activation function, a neural network is a universal function approximator capable of learning any mathematical function. In contrast, if you only have linear layers, then you can add as many hidden layers as you like, you never get a universal function approximator. So there's also another activation function widely used. This is tanh. So tanh has the advantage, as you can see, that it also covers the negative range. So if you have data which is in the negative range, tanh might be better, and it's also used in the output layer of binary classification. In case of multi-class classification, the output layer uses softmax. So softmax is defined as a function which takes a value c and then takes e to the power of it, and then it divides by the sum of e taken to the power of all the other c values. So this softmax function has the property that all class probabilities are summing to 1, and in case of a multi-class classification, the actual class you have predicted will resemble in a value close to 1, and all other classes are resembled in values close to 0. So this activation function ideally fits to one-hot encoded vectors in the output layer. So this is another activation function which is called ReLU. So ReLU doesn't really look nonlinear, but actually it is, because a linear function is only a line, and it turns out that with a combination of multiple ReLU activation functions you also can approximate any mathematical function. ReLU is the most used activation function today. This is first of all because the computational complexity is less, and neural networks also tend to converge faster using ReLU. One problem with ReLU is that it can cause dead neurons because of a range where the output is 0. Therefore, there's a variation of ReLU. So this is called leaky ReLU. As you can see, on the negative side there is a little value, and that increases the value range and also prevents dead neurons. So in case your neural network training doesn't work perfectly, you just can try leaky ReLU, or there's also a variation called random ReLU. So it's best to start with ReLU for the input and the hidden layers, and for the output layer it depends on your task. So if you are building a regressor, you use a linear output unit, and if you are creating a classifier, you use softmax or sigmoid. And nobody, of course, stops you from trying other things. So in the next video we will tell you something about the bias variance trade-off, or in other words, how to prevent overfitting of a neural network.